Okay, so this video is for Ronald from Haiti. You guys are making me feel so international, I have to tell you. But Ronald struggles with some probability problems, especially dependent probability. So he sent me over 4 word problems, all to do with the subject. They're all a little different, so let's take a look. Of course, I changed the problems up a little bit, as I have to do, guys, when you're taking them from a textbook, because I don't want to steal from other teachers. Okay, so here we go. Pedro the magician shuffles the cards pictured above. So clearly I'm not an artist, but we can see we have some cards up here that are kings and queens and jacks, and places them face down. If 2 cards are chosen at random, what is the probability that they will both be kings? Okay, I'm going to organize my work a little bit. Currently, the man has 3 kings. He's got 2 queens, and he's got a jack. When you deal with probability, more than one event happening at a time, what you're going to do is you're going to take the probability of the first event, multiply it by the probability of the next event, and so on and so forth. You keep on multiplying each probability together. Now, we're only looking at 2 events because we're looking at drawing 2 cards at random. Let's deal with the probability of the first event. The probability of the first event, well, probability is always measured by what I call wins over total. That's how you measure probability, wins over total. So we're looking for the probability that he draws a king the first time. Well, if you take a look at this, he originally had 3 kings. So it's a 3 out of 6 shot. 3 out of 6 shot that the card that he draws will be a king, because there's 3 kings and 6 total cards. I hope that helps. 3 winning cards, 6 total cards. Okay, but now you have to realize what happened. He just drew a king. This deck is going to change. It won't be the same probability for a king the next time, because the next time he'll only have 2 kings left here. So now the new probability that he draws a king for the second time around is 2. And careful, there's not 6 cards anymore either. That number also went down when he drew a king. So 2 out of 5. Now, of course, we're multiplying fractions, which is one of my favorite things to do because it's super, super simple. If you guys just remember, all you have to do to multiply a fraction is multiply straight across and reduce. And if you're really lazy like a mathematician, you reduce before you even begin to multiply using what's known as cross reduction. So I take a look at 6 and 2. They have a common factor of 2. I'm going to divide it out of both of them. 2 divided by 2 is 1. 6 divided by 2 is 3. I see 2 more numbers that have something in common. Here's a 3 and a 3. It doesn't have to be across from each other as long as we have a number in the numerator and a number in the denominator that have a common factor. You can divide it out. And as you know, when 2 numbers are the same, they always cancel to be 1. I'm dividing them both by 3, basically. I'm just being lazy about it. So dividing them both by 3, I'm left with 1. And now there's only 1s and a 5. We have nothing else in common. And so we're just going to go ahead and multiply across. So 1 times 1 is 1, and 1 times 5 is 5. The probability for this problem that he draws 2 kings is 1 out of 5, or 1/5. Sometimes you will be asked to express probability as a decimal. If you were going to do that, you would just divide 1 divided by 5, and I promise you, you would get 0.2. Or you might even be asked to do it as a percentage, and that would be just taking the decimal and bumping it once, twice over. So that would be the same as 20%. Probability can be written any of those ways, but it almost always starts in the fraction form. Okay, so that's my first example. Let's go ahead and look at the other problems. Next one, there are 30 marbles in a bag. 20 are blue and 10 are green. 1 marble is drawn from the bag and set aside. Then another is drawn randomly. What is the chance that both marbles will be blue? Let's take a look. Again, let's organize our work. According to us here, we have 30 marbles. Now, they don't designate the color here, so this is my total number. 20 are blue. And, I should have done this the other way. Let's stay consistent. There we go. Let's go total 30, blue, 20, and for green, we've got 10. Now, again, in this problem, we have two events happening again. First, we see one marble being drawn from the bag and set aside. Then, we have another being drawn randomly. And we want the chance that both marbles will be blue. So we want blue on the first draw, and we'll multiply that by the chance of blue on the second draw. Okay, you multiply the various events when you do probability. So let's look at the chance that he's going to get blue on the first draw. Well, he's got 20 blue marbles, but out of how many total? 20 out of 30 marbles are blue. Now again, don't forget to account for the fact that he took a blue marble out and he put it away. He didn't put it back in the bag. So he doesn't have 20 blue marbles anymore. He has 19. So the chance that he draws a blue marble next is going to be 19, and be very, very careful. It's not out of 30. Taking a marble out of that bag is going to change the total as well. This number will go down to 29. Beautiful. And now we can multiply this problem. Now, I happen to know that 29 is a prime number. It's not going to reduce with anything over here because none of these numbers are divisible by 29. So is 19. So I'm just going to worry about reducing here. Well, both 20 and 30 divide by 10. And if I were to divide them both by 10, again, you can always reduce before you multiply fractions as long as you reduce one number from a numerator with one from a denominator. So I want to divide them both by 10. I get a 2 here. I get a 3 here. And then I'll just multiply straight across. 2 times 19, let's see, we'd go to 40 and back it up by 2, so 38. And 3 times 39, let's see, 90, back it up by 3, 87. Okay, so this particular probability is a little messier, but still good, 38 over 87. And a lot of students will ask me, Kate, can this reduce? A very good question. But you know how these numbers were built. You built these numbers out of 2, 19, 3, and 29. If they didn't have any common factors here, they won't have any common factors there. And that is actually my defense for why I think you should learn to cross reduce. Okay, so that's my probability for that one. 38 out of 87 chance. And again, if you wanted a decimal version or a percent version, you would just divide it through 38 divided by 87. You probably wouldn't have that ugly of division on the GED. So I'm not going to worry about it, at least not without a calculator. Let's move on. Next one. A child flips a coin 6 times. What is the chance that she flips tails every time? Now this one's different. It's not a dependent probability problem anymore. In fact, this is actually the easier version of the last problem. Why? Because when you flip a coin, the coin doesn't change. Nothing changes. If you think about it, this kid is going to flip a coin 6 times, so I need to multiply together 6 probabilities. But it's super duper simple because if you think about it, the chance that you flip tails on any given time, well, tails is one of the sides on a coin, one out of 2 sides. If you think about a coin, there's just 2 sides on it. You know, one is tails and one is heads. Those are my only 2 options. And so if it's a fair coin, you just assume that we have a 1 out of 2 shot of getting tails. And guess what? When you flip the coin, it's not going to change. It's not like the tails goes away after you flip it. So the next time the probability will be 1 out of 2. And the next time, 1 out of 2. And the next time, and it doesn't change. One flip is not dependent on another. Now, I can do out this multiplication, but I want to point out to you a shortcut that a lot of lazy people will use. They'll say, that's like I had 1/2. 1, 2, 3, 4, 5, 6 times. So there's 2 different ways to think about this problem. Repeated multiplication, or as many of us know, you can rewrite repeated multiplication using exponents. Either way, the problem is going to simplify the exact same way. We multiply across this top. 1 times 1 times 1 times 1 times 1 times 1 is just 1. I don't care how many times you multiply 1 by itself, you get 1. Now, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we've got a 1 out of 64 shot that she's going to flip 6 tails in a row. Okay, last one. This one says if you roll 2 dice, what is the probability that both will be an odd number? Once again, I have 2 dice going on, so let's look at 1, 2. So let's look at the probability that the first dice will be an odd number. Well, if you think about a standard die, there's one that has 1 dot, there's a 2, a 3, there's a 4, there's a 5, and there's a 6. Well, how many of those are odd? The 1's odd, the 3's odd, the 5's odd. 3 out of 6 are odd. Some of you guys are like, Kate, that's a half. Yes, you're right, that's a half. If you write a half, you're going to get it right. Now think about the other dice. It's also a standard dice. How many of those are going to be odd? Of course, that's also going to be 3 out of 6. Now this problem is super easy to reduce because as many of you guys know, 3 out of 6 is the same as 1/2. If you're like, what is Kate talking about? Realize that 3 and 6 are both divisible by 3. I'm dividing out the 3 they have in common. And again, as long as one number's on the top and one number's on the bottom, you're allowed to cross reduce. Okay, now I'm going to multiply straight across the top. 1 times 1 is 1. And I'm going to multiply straight across the bottom. 2 times 2 is 4. I got a 1 out of 4 shot that both will be an odd number. Now, I do want to show you one more way to work this problem because there's multiple ways they'll teach in a probability class. Maybe you learn this a different way. So I want to look at it this way. We could look at every possible roll of the dice. If you think about it, I could roll a 1-1, a 1-2, a 1-3, and so on and so forth. I could roll a 1-4, 1-5, 1-6. And if I wanted to, I could sit here and list out every possible roll of the dice. It takes a little bit longer, but some students have an easier time understanding this problem this way. So give me a break here and give me a little bit of time, some patience as I list out every possibility for this. And notice that I'm being very, very systematic about it. All the rolls with a 1, so I don't miss any. If you miss one, this whole method will have been wasted. So I'm almost done. Now I'm on my 6s with the first dice, I mean. 6-3, 6-4, 6-5, and 6-6. Yay, all the possible rolls. So I listed out all the possible rolls with my first dice being a 1, all the possibilities with my first dice being a 2, a 3, a 4, a 5, 6, and so on. Well, now I'm looking for both of them to be an odd number. So 1-1 would both be odd, 1-3 would both be odd, 1-5 would both be odd. I'm going to skip this whole row because 2 is not odd, but 3-1, 3-3, 3-5. Again, I'll skip a row, 5-1, 5-3, 5-5. Let's try the problem this way. It better match what we did before. Good math always works, right? Right? Let's hope. Let me just erase, give myself some space here. Okay, so let's see. How many are winners? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9 winning rolls out of how many total rolls? Well, I see 1, 2, 3, 4, 5, 6 rolls in each row, and 1, 2, 3, 4, 5, 6 rows. I could count them up, but I'm too lazy. 6 times 6 is 36. Great. Now we're almost done, but as we know, all final fraction answers must be reduced. I happen to know that both of these numbers are divisible by 3. I'll pull a 3 out of both of them. 9 divided by 3. 9 divided by 3 is 3. 36 divided by 3 is 12. These numbers still have a 3 in common. Let's pull them out. To reduce a number, you pull out all the common factors. 3 divided by 3 is 1. 12 divided by 3 is 4. And take a look at that. Good math always works. Okay, great. I hope this video made sense. If it didn't, drop your questions in the comments and I'll do my best to answer them. And as always, leave a question right on my Facebook page if you want it answered or on my YouTube page.